99, welcome to Simplifying Surds. So, as you can see, I have taken the approach of using brown today. You are welcome, James and Delaney. I know you'd love it, so hopefully you're watching this to see that. So, some interesting things to note about surds. I've also decided to add some little Bitmojis just to make it a little bit more interesting. So, you cannot take the square root of a negative number. Why? Well, if you think about what taking the square root actually means, it means what number, when you square it, gives you the number under the square root. So, for example, the square root of 4 is 2, because 2 squared is equal to 4. Now, you cannot have a negative number squared give you a negative number. Therefore, you can't take the square root of a negative number because any negative number squared ends up as a positive. Another thing to note is this property here. So if you have the square root of a number and then you square that, you actually just get back the number that you started with. So for example, the square root of 4 all squared means the square root of 4 times the square root of 4. Now, the square root of 4 is just 2, and 2 times 2 is 4, which is the number you started with under the square root. So, for example, let's simplify some of these. The square root of 7 all squared. What that means is the square root of 7 times the square root of 7. Now, this just simplifies to literally 7. Cool, right? And the reason for this is, which I'll show you over the page, the square root of 7 times the square root of 7 is actually equal to 7 times 7, all under the square root, like they're the same, which is the square root of 49, and the square root of 49 is 7, okay? All right, the next one, so we've got 3 square root 5 times 3 square root 5. Now, 3 square root 5 is like saying 3 times, the square root of 5. That's what that means. It's not the cubed root because it's bigger. If it was a cubed root, it would have a little 3. So what this means is we can kind of expand that out a bit further to say it's 3 times the square root of 5 times 3 times the square root of 5. And like algebra, you group things that are like terms. So we've got the numbers out the front are what we group together, and then the surds we also group together. So rearranging it, we can have, well, 3 times 3 is just 9. Might move that down a little bit. And then the square root of 5 times the square root of 5 is just 5 from this property here. Okay, so that's just that times that is 5. So 9 times 5 equals 45. I'll run out of room again. Whereas for this one, again, it's the same thing. It's like saying negative 2 square root 3 times negative 2 square root 3. Again, you want to group the things that are the same. So the negative 2's are the same, and the square root of 3's are the same. And when I say the same, it's not necessarily because they're the same number. Well, it is, but also the same because they're the number at the front of the square root. So it could be, like, for example, you could have 2 square root 3 times 4 square root 3. So you group the numbers out the front first. So 2 times 4 is 8. And then times square root of 3 times the square root of 3. That's what I mean when you group the things that are the same. So for this scenario, we've got negative 2 times negative 2 gives us positive 4. And then the square root of 3 times the square root of 3 equals 3. Okay, and that would give us 12. Now, I hope that made a little bit of sense. because the next thing we're going to look at is this property here. So we can simplify surds just on their own. And the reason why we can do this is because we can break it up into factors. So if we've got the square root of 50, what you want to do is break the number 50 up into two factors. So numbers that multiply to give you 50, where one of them is a square number. And what that means is a square number is you can take the square root of it and it gives you a whole number back. So 9's a square number, or 25 is a square number, or 16 is a square number, okay? So all of those are square numbers. So what are the factors of 50 where one's a square number? Well, we've got, oopsies, 25 times 2, okay? Because both of these give you 50, okay? We haven't changed anything. Both of those give you 50. Now, from across the page where I showed you this, that those two things were the same, that's where this has come from. So then we can say, well, that's the square root of 25 times the square root of 2. And we know that the square root of 25 is actually just 5 times the square root of 2. We can't do anything with that, so we just leave it as the square root of 2. And an interesting thing that you'll note is that if you put that into your calculator and that into your calculator, you'll get the exact same answer. So you're not changing anything. So the square root of 50 equals 7.071 ... Okay, it goes on forever. And then 5 square root 2 is also equal to the exact same number. Okay, so that's why it's called simplifying, because you're just making it easier. All right, the next example, two numbers that multiply to give you 432, where one's a square number. So the numbers that give you that is 144 times 3. Now, the way that you can find the square number is by just go through and divide this by square numbers, okay? Or if you can think of it in the top of your head. Otherwise, just get that into your calculator and start dividing it by square numbers. So remember, they're the numbers like 4, 9, 16, 25, 36, okay? Anything that when you square it gives you that number. Now, we know the square root of 144 times the square root of 3. Square root of 144 is just 12, okay? That's why we want a square number, to get us a whole number. And then times the square root of 3, we can't do anything with that, so we just leave it as 12 root 3. All right, next one. So this time we've got a number out the front. So remember, this is the same as 4 times the square root of 12, okay? Then we do the same thing. Let's break 12 up into two numbers where one's a square number. So those numbers are 4 times 3, okay? So then we've got 4 times, we can break that into two separate square roots. So 4 times the square root of 3. That just equals 2. So 4 times 2 times the square root of 3. Again, we group the things that are the same. So the numbers on their own are the same. And the surd is on its own. So 4 times 2 equals 8. And then we can't do anything with that. So we leave it as the square root of 3. Easy. All right, last one. Breaking up 288 into its numbers, we get 144 times 2 all over 2. Remember, 144 is just 12, so I'm going to go straight to 12 square root 2 from the same reason that this was 12 square root 3, okay, because it was times by 3. So this is going to be 12 square root 2. Divide that by 2. Now what we can do is simplify this because we've just got the numbers. So when you've got the things that are the same, you can simplify further, okay? So the numbers on their own are the same. Now, what's a number that goes into 12 and 2? Well, that's 2. Whoops. And that goes into itself once, goes into 12 6 times, and then we're left with 6. Oh my God. Is it 2? Yeah, sorry. Yep, just had a moment. All good. 6 square root 2. Okay, I really hope that made sense for you. Here you go, I'll add another Bitmoji for you. And good luck with it all.